Alright, so the question was that I was asked to do was number 132 on the CP exam, which corresponds to number 130 on the honors practice final exam. And the question says, what is the shape of this molecule? And the formula we're given is BF3. BF3. You must first start with the electron dot formula. For that, you're going to go to your periodic table and you're going to figure out how many valence electrons there are around the two atoms that you're interested in. Well, the boron here is located right here. And we're only interested in the valence electrons now. The valence electrons are the outermost electrons, and those are the electrons represented by the elements in that row of the periodic table. Each row of the periodic table means you have another level of electrons, so we only care about the outermost ones. That's the ones in this level. So all we got to do is go back to the left, and starting with the element lithium, count 1, 2, and then 3 for boron, and that means we have 3 valence electrons around a boron. So we're going to write boron with 1, 2, 3 valence electrons as dots. Now, the electron dot formulas, you put 1 electron on each of 4 sides. Got a top side, a bottom side, a right side and a left side. You can choose any of the 4 sides you want to, but you put 1 electron on each of the 4 sides. Now in this case we didn't have to worry about it, but once you reach 4, then you can pair up if you need to. And you will only have 8 electrons when you do this. The maximum number can be 8. This one stops at 3, that's where we stop. And we're going to combine boron with fluorine. Fluorine is 1, 2, 3, 4 steps away from boron. So if boron had 3 electrons, carbon will have 4, nitrogen 5, oxygen 6, and fluorine will have 7 electrons. So we're going to put 7 electrons around the fluorine. 1, 2, 3, 4. Once we have 1 on each of the 4 sides, then we can pair up 1, 2, 3 more, or 7 electrons. We're going to have 3 fluorines, so I'm going to put 2 more fluorines, each fluorine with 7 electrons. So those are the electron dot formulas for the 3 fluorines and the 1 boron. Where did I forget a dot? Oh, I did, didn't I? Left one off right here. Okay, so now what we want to do is to share electrons in such a way as to try to get the atoms to have a total of 8 electrons. Well, I can share these 3, or these 2 right here, and these 2 right here, and these 2 for 3 shared pairs, and there's, in this case, nothing else I can do. So boron is stuck with 8. It can't go any further. I can't take some electrons over here from a fluorine and just stick it over there. Can't do it. You can't move an electron from fluorine over there because the only elements that you can move electrons around in that way would be in the 3rd row or higher, but these are both in the 2nd row, so they can't go any higher than that. We're done. Okay, which means that this is not going to have 8 electrons. So there are rare cases where you're going to violate the Octet Rule. The Octet Rule says most atoms want to have 8 electrons, and you share electrons or move them around in order to get there when you're bonding atoms together. Well, this is where we have to stop with this one. Now, the next step is to find a Lewis dot formula. The Lewis dot formula takes these shared electrons and squeezes them between the 2 atom symbols. So between this fluorine and this boron, I want to squeeze the 2 electrons in there, and they kind of squirt out over and under. Okay? And on this side, we're going to do the same thing. They're going to squirt out over and under. But down here, where I push the fluorine up against the boron, they're going to squirt out side to side. Now we have to continue to put the remaining electrons, the ones that are unpaired, the unshared or unpaired electrons on these fluorines must remain in this drawing. Okay, and so there's our Lewis dot formula. So we started out with an electron dot formula, and then we circle the electrons to show how they shared, so that became a sharing arrangement. This problem doesn't ask you to name it, but I'm reminding you what it's called. And this is called a Lewis dot formula. Alright. So once we have a Lewis dot formula, then we can go to start building our three-dimensional arrangement. Alright, and this is what it's asking for, the shape of the molecule. That's what our three-dimensional arrangement will be. I have 3 sets of electrons around the central atom. 3 sets of electrons around the central atom. Okay? 1, 2, 3 sets of electrons around the central atom. What I want to do is arrange those 3 sets of electrons so they're as far apart as they can be in 3 dimensions. Up, down is 1 dimension, side to side is another dimension, out toward you and back away from you is a 3rd dimension, 3 dimensions. If I have 3 sets of electrons, I can only get them 120 degrees apart to have them the maximum distance you can get them apart. So if I have a boron here, I can have 1 set going up like that, 120 degrees is like this, and another 120 degrees is like this. That's as far apart as they can be. And that's flat on the paper. There's no electrons coming out toward you or going back behind the paper here, because this one doesn't require that. You don't start putting them, arranging them so they're going back away from you and out toward you with triangles and dotted lines until you get to a tetrahedral. Okay, this one's flat. So this we called the electron dot formula. Electron pair shape. And when we have just 3 sets around that central atom, the electron pair shape makes a trigonal planar shape. Trigonal because there's 3, planar because it's flat, like a plane. Not like an airplane, like a plane in geometry. Okay? Trigonal planar shape. The next step then is to take, and wherever electrons are shared, we're going to put the elements on there. The element symbols or the atom symbols on here. So on each of these corners, I'm sharing those electrons with fluorine. I don't put the lone pairs on here. I put the lone pairs on here when we're doing a Lewis dot formula. I don't put the lone pairs on there when I'm doing a 3-dimensional shape. So now this is still trigonal planar because the shape really didn't change. And this is not an electron pair shape. We don't have any electron pairs left. So since there's no electron pair shape, no electron pairs left, this is the molecular shape. And that's what we're looking for. We're looking for the molecular shape. And so the question asks, or it prompts you to ask, what is the shape of the molecule? The shape of the molecule is trigonal planar. That's the shape of the molecule. Trigonal planar.